Now let us learn what happens when metals are burnt in air. Activity 3.9, and this is to study the reaction of metals with air. The things required for this activity are copper, aluminium, sodium, potassium, pair of tongs, Bunsen burner, water and a watch glass. Step 1. Hold the samples of copper, aluminium, sodium and potassium with a pair of tongs and heat them over a Bunsen burner as shown here. Collect the ashes in each case if obtained and let the metals and the ashes cool down. So what do we observe? We record different observations for different metals. First, let us consider copper. When copper is heated in the presence of air, it combines with the oxygen present in it and forms copper-2 oxide, which is black. Copper does not burn, but it gets coated with black coating. On prolonged heating, copper oxide can be collected. Next, let us see what happens when aluminium is heated in the presence of air. Now look what happens here. When aluminium is heated, it combines with oxygen to form a white crystalline solid, which is known as aluminium oxide. We have already studied about the reaction of copper with hydrochloric acid. Also, in the previous section, we have learned that most of the metal oxides are basic in nature. But few metal oxides, such as aluminium oxide and zinc oxide, show both acidic as well as basic character. Such oxides are called as amphoteric oxides. Now these metals react both with acids and bases to yield salt and water. Aluminium oxide reacts with hydrochloric acid to give aluminium chloride, which is yellow in color, and it reacts with sodium hydroxide, which is a base, to produce sodium aluminate, which is white in color. Notice, in both the reactions, there is a formation of base and water. Similarly, sodium and potassium also produce their respective oxides after getting heated. Now let us speak out our observations when we dissolve all the metal oxides in water. Most metal oxides remain reluctant towards water, whereas some metal oxides such as sodium and potassium oxides dissolve in water to form their respective alkalis. So why is potassium and sodium kept immersed under kerosene? In activity 3.9, we have already learned that different metals react with oxygen at different rates. Sodium and potassium are highly reactive and reacts vigorously with oxygen. The reason why they are kept immersed under kerosene is because they don't react with kerosene. Metals such as magnesium, aluminium, zinc, lead, etc. are covered with thin layer of oxide at ordinary temperatures. This prevents the metal to get further oxidized. On heating, iron metal does not burn, whereas iron fillings do burn. Silver and gold do not react with oxygen even at high temperatures. Anodizing is a process of forming a thick oxide layer of aluminium. When exposed to air, aluminium develops a thin layer of oxide on its surface, which makes it immune from any further corrosion. This immunity is increased on further increase in the thickness of the layer. In the process of anodizing, a clean aluminium article is made, the anode and electrolyzed with dilute sulfuric acid. The oxygen evolved at the anode reacts with the aluminium, making the thick layer. Now this layer can be easily dyed to give aluminium a shiny, attractive finish.